Hello, everyone. Welcome to the next in our High Noon series. This is number 5. We're talking about building MySQL HADR clusters at the Geo-Scale. And today we're going to be looking at InnoDB Cluster and how it compares to Continuent Tungsten clusters. Again, we want to build a Geo-Scale MySQL deployment, whether that's in the cloud, on-prem, or maybe a mixture like hybrid cloud or multi-cloud. My name is Matthew Lang, and I'm a director of customer success here at Continuent. And so a little bit about me. I'll get back to that picture in a second, but I've always been into Linux, MySQL, and cloud. I actually started using Linux in the 90s, and I've been using it for my professional career ever since. I really enjoy working at startups, and I've been fortunate enough to work in several startups where there's been exponential growth in employees and sales, and whether that's in automotive, steel, medical, and now tech industries. So I've done MySQL DBA work. I've been a Linux sysadmin. I've been a site reliability engineer and a cloud architect. And one of the more interesting things that I've done is I made a replication system for a proprietary database. And that's actually still in use at that company. They have not replaced it, even though I am no longer there. And on the weekends, I like to go and play out, do some concerts or something like that. A little hard right now, but hopefully soon we'll all be back out and I'll be able to do my thing again. So a little bit about Continuent before we move on. We are the MySQL availability company. And let me just talk briefly. How do we fit in? Why are we in authority to talk about this? Well, we've been around since 2004. We've seen open source uh, really take on a life of its own, and we've seen cloud computing rise. And we've really been at the forefront of the MySQL market. We've witnessed MySQL become extremely widely deployed. And in the beginning, there really was no high availability solutions for MySQL, let alone any sort of clustering solutions or Geo-Scale solutions. And that's where we come in. Uh, we do high availability, clustering, and Geo-Scale. And again, we've been doing this since 2004. So we're not a huge company. We're not the biggest, and that's really not our goal. We just want to be the best at this. And again, that's the best at clustering, highly availability, and geo-deployed, highly available MySQL. So maybe you've seen the previous High Noon webinar, but if not, what we want to do is look at several solutions to deploy MySQL at the geo scale and look at highly available solutions. So what we're looking for is rapid failover in the local network so that we have high availability for our applications. We would like to have our applications geographically distributed so that we have low latency data replication with a consolidated view, a consolidated management view. Uh, Obviously, we want good performance, fast local response times for our read traffic. Um, and we want to deploy not just at a geo scale, but we want to have active MySQL primaries in multiple regions. So there would be an active database in each region that we deploy in, or each site, each cloud provider, whatever it may be. Of course, if we have an existing application, we really don't want to change the application code. We want to be able to deploy our solution without changing our applications. One other thing too is to deploy complex schema changes without taking down our applications. This has traditionally been a challenge really with any solution. So we want to see, how can we do that? What solutions are going to allow us to do that? And then also too, let's try to avoid provider lock-in. If we're locked into one provider, obviously we don't have choice, and it could be really expensive in the long run, in the future for our application. So, and also too, when we're talking about MySQL, we really mean MySQL, MariaDB, and Percona Server in any version. So let's get into the High Noon series. This is a new series where we are comparing other MySQL clustering products to Tungsten clustering. And we're going to look at a bunch of products. And what we do is we do a deep dive with each product and we rank them and we figure out what features they have, what they don't, and how well each feature works. And we're able to roll them up into kind of a scoring system, right? From 1 to 5 in each of these areas. And when you're looking at a package for an enterprise cluster, these are pretty much, the main features that you're going to be looking for. Continuous operations, right? You want your cluster to be running, your application to be online 24/7. You'll probably want to be able to scale it as well. Hopefully, you're going to have an increase in traffic, increase in business, or more drive to your website. So you want your backend cluster to be able to handle that. Um, are you going to be able to do a geographic deployment, right? Or a geo deployment? Or is it just a single region only? So we'll look at that as well. And then how is the overall performance? Are we going to take a performance hit by putting in a cluster, or are we actually going to be able to improve the performance of our application with our cluster? And then what is our application see when it connects to our cluster? Does it have to be modified? Is there some sort of change that needs to happen? Or can we just install the cluster and our applications are going to work fine? And that's what we mean by transparency. And then, of course, security is always a big issue. And so we'll definitely look at that. And that's something that's coming up more and more. So we definitely want to make sure that all of our products do support good security. And then, of course, once we get this deployed, it might be a complex system. We need a good tool to manage the entire deployment and the entire topology. And with that, too, we need to be able to monitor what's happening within our cluster so we can react if things don't look right. And then lastly, once we have our complete topology, our complete deployment all set up and running, how easy is it to replicate our data out or get our data out and load it into some analytics tool where we can have a look later and run complex analysis on our data? So one other thing too, really important, is support. Um, there are always going to be questions, always going to be issues, or maybe something that you just don't understand. And so, where will you get your support? Some options are online forums, right? Maybe not the best place or the most up to date information. The information in a forum isn't necessarily verified. um, Perhaps it's an email system, right? Where you email support and then the next day you'll get an answer and you'll reply to that and wait another day for an answer. Or maybe you actually get a live person, an engineer with experience. That's obviously worth a whole lot more because you can get your questions answered much more quickly and get it directly from the source. So we'll see how all these solutions compare with support. And then, of course, we talk about intangibles, right? We're clustering MySQL. So, what versions of MySQL do we support, right? Or which ones does a particular solution not support? So, that's also important if you need certain features in a certain version of MySQL. And when we say MySQL, that could be MySQL Enterprise, MariaDB, Percona, any one of those variants. Platform's important. Are you going to be deploying in the cloud, hybrid cloud, maybe on site? So whatever solution we pick has to support our target deployment. And then product maturity, I think that goes without saying. The more mature a product, the more time it has to have bugs worked out and features put in as well. And then with all this said and done, what's the total cost of ownership, right? And how much does the physical software or all the pieces cost? But also, what about support? And what about man hours and learning the product and, really time spent on implementation, right? And that's what we call total cost of ownership. And then lastly, what we'll be looking at are the various use cases. So we see right here, we can have a quick look. We have pretty good support for HA. Each product handles it a little differently, some better than others. And we'll look at how they handle HA. DR, or disaster recovery, not everyone supports that, but it might be something that you need. You may want to avoid a catastrophic situation in a particular region, and you may need to fail over to another region or another site. Zero downtime maintenance is also important. And I think every DBA has gone through this where there has to be some major maintenance. How is that going to impact the application? Or does it even impact the application at all? And again, that flows with continuous operations, right? We need our application to be up, especially for large enterprise applications. We can't afford downtime. Um, and that includes maintenance. Okay. And then what about some other features like having multiple primaries? Is that something that we want to have? How about a geo-deployed active passive cluster? So we can fail over and we can also fail back and we can leverage the DR site maybe for reads. Getting even more complex active-active clusters, right? Deploy a Geo-Scale topology where you have multiple active clusters and all replicating to each other and all in sync. And this goes, again, leads into Geo-Scale clusters, right? Can we deploy globally and have our applications close to our end users? So now let's look at MySQL InnoDB Cluster. It was released in April 2017 directly from MySQL from Oracle in version 5.7. So it's fairly new and it's been really improved starting with version MySQL 8. If you're going to deploy InnoDB cluster, it would make sense to use version 8. And not only has it been improved, but the deployment is a lot easier in version 8 version versus version 5.7. And also, just when we talk about InnoDB cluster, what is that exactly? So it's a wrapper for replication, and it also includes a basic MySQL proxy and the MySQL shell, which makes it easier to deploy and maintain. So really, InnoDB cluster replication is kind of the same thing, but InnoDB cluster really means the whole package with a MySQL shell and a basic proxy. You can deploy a single primary or multiple primaries in a site. And group replication, we'll talk about that in a minute, but replication means that the nodes are joined by a group and there's a group chat to be able to decide if transactions should be committed or not. And there's even some conflict resolution when you have multiple primaries. Uh, this, of course, includes automatic failure detection. If you have a single primary, then a replica will be promoted to primary. So let's talk a little bit about MySQL group replication, right? Uh, it's what they call virtually synchronous. It has synchronous elements to it. But it's a distributed replication system. Members join or leave the group. They join either by someone adding them, or they get put back in after a failure, or they leave either by manually telling the node to leave the group, or they fail. It's available as a MySQL plugin. And we have two modes, single primary mode. If a primary leaves the group, a new primary is elected. And by the way, if you have a 3-node cluster, you can lose one node and run with 2 nodes, but you cannot lose more than one. We always need a quorum and a majority when running MySQL group replication. Uh, the new primary may have some backlogs of transactions to apply, so it may take a minute or two for it to catch up. Interestingly, you can also specify a wait for nodes to be elected to primary. So suppose you have one node and you would really prefer that node to be elected to primary. If the main primary fails, no problem, you specify a higher weight for that node. And then we have multi-primary mode. So that's what used to be called multi-master. A transaction is executed on one node, and then that transaction, before it's committed, is broadcasted to all nodes in the group. And the nodes at this point certify or reject the transaction based on conflicts or not. Um, if it's accepted, then it's written to the binary log on the executing node and committed on that node. And on the other nodes, it's written to the relay logs to be executed, put in the queue to be executed, and then committed. So you can see where there's a synchronous element, right? That's the broadcast to the group. And then in the background, after it's been certified, then that happens kind of asynchronously. So what if we want to go multi-site, right? Because that's kind of what we're talking about, deploying at the geo scale. Well, if you're using group replication, again, it has elements that are synchronous, and your members have to be a part of the group and participate in group communications. Really, over a WAN, this is not practical, and we really can't deploy a geo-scale group replication cluster. So how else would we do this? Well, we would use asynchronous replication like MySQL native replication to join the clusters, but this can get pretty complicated. Management becomes really complicated with this, and we have to make sure that our asynchronous replication knows which source site to point to, and that's not really that easy. So deploying this at the geo scale really gets pretty complicated. In general, what are some of the general limitations? Well, a lot of writes may slow down the cluster because there are synchronous elements in replication, and it has to go through a certification process for each transaction. Um, Again, poor WAN performance, and it's really not feasible to deploy this over the WAN. In that case, multi-site or hybrid cloud technology or topologies aren't really used with InnoDB Cluster. You do get a proxy called MySQL router, but it's pretty basic. So for instance, your applications are going to get disconnected during a failover. So that's not good. Your users may see errors at that point. Um, all tables must have a primary key, which actually really is best practice. It only supports InnoDB tables. That's why it's called InnoDB Cluster. So if you have, say, MyICM tables or even other tables, table types in use, it's not going to work with InnoDB Cluster. And if you want to replicate to some other target, say other than MySQL, uh, you really have kind of limited options here. You have to use a different method, maybe MySQL native or some other third party to be able to replicate out of the cluster. And then again, it's really not that mature in MySQL 5.7, definitely some limitations. And you'd want to use MySQL version 8 if you're going to deploy InnoDB cluster. So how do we approach building a better MySQL GeoScale solution? Well, here at Continuent, we have our proven solution, Tungsten Clustering, right? This provides continuous MySQL operations, so highly available, uh, zero downtime maintenance, so we can do OS patching, MySQL patching, maybe upgrading to the latest version with no downtime. We fully support geo-distributed MySQL clusters, and really we accelerate on that, and we'll see that in a few minutes. And along those lines, we support cloud, multi-cloud, or hybrid cloud. So you can deploy in two cloud providers if you would like, or deploy in a cloud and on-prem at a geo scale. Okay. Included is the Tungsten Connector, which is an intelligent proxy for MySQL. It speaks to MySQL protocol, and it can handle read-write splitting automatically, so no changes to your application. Or if you have this functionality in your application, great, we can leverage it. And we support MySQL off the shelf. No changes to your application. Just use whatever MySQL version you'd like. And of course, as I mentioned, that includes MariaDB and Percona Server. Let's have a look at what we call active passive clustering, right? So we can scale a cluster to multiple regions, multiple data centers, or multiple clouds, or a combination of all of that. Uh, and we really don't care if it's what cloud provider you use, if you're going to deploy it on a VM or directly on the servers. We run on really anything. Uh, and this particular topology is active passive, which means there's one site, one single site that is active and has a primary, which is a read and write database. And then all other sites are replicated from that primary cluster. And we can manage this cluster from any node within the cluster. And we can also fail over or move the primary from one site to another site. So if we have, say, in one region, maybe an outage, or we're going to be doing some maintenance on that region, we just fail over and activate the other region to become active. And then when the first region comes back online, it catches up with replication and gets added back in the cluster. And we can switch back or fail back with a single command. So just another kind of contrast. This is active clustering. And really, Continuent is the only one doing this right now. So this is where, again, multiple clouds, data centers, whatever hardware, but all clusters are active. So each active cluster has a primary that you can read and write from. And with this, you can deploy your clusters close to your users so they get the best performance. Your local users can read and write to a local database. But all these clusters are in sync with each other, and each one is active. And in a failover situation or a failure of a single site, we just redirect the traffic to another site within the cluster, and we're good to go. Again, everything is replicated between each other, and if that failed site, when it comes back online, we just add it back into the cluster and replication catches up automatically. How about we mentioned zero downtime maintenance? Uh, how would we do that? Well, let's say we wanted to upgrade MySQL. So one thing with tungsten clustering is you can mix MySQL versions, which within the cluster, and we fully support this. And this is really an avenue of when you want to upgrade MySQL. You can take a replica, remove it from the cluster. We call it shun. Go ahead and upgrade MySQL and return the cluster, return the node back to the cluster. And we're good. Replication catches back up, and if for some reason there's an error, we can just discard that node and reprovision it in a couple steps. But assuming most MySQL upgrades do go pretty smoothly, now our replica is upgraded. So we repeat that process for the other replicas and our cluster until finally our primary now is on the old version, but all the replicas are on the new version. So we do a command, we just do a switch that promotes a replica to primary and the primary to a replica. So now on the old primary, we upgrade MySQL and we're all done. No downtime and application is up. And really, this all happens in the background. And when we talk about transparency, no one notices because this is all happening in the background, leveraging tungsten clustering to allow zero downtime maintenance. So now let's circle back to our scorecard and look at how tungsten clustering compares to MySQL's InnoDB cluster. Talking about continuous operations, both of these products really handle continuous operations, right? We have high availability, automatic failover, and also zero downtime maintenance with both products. But when we're talking now about DR, whether we have an active passive cluster or maybe two active clusters where we're really just using one and failing over to the other, uh, that's really tungsten clustering, right? That's baked into the product. With MySQL InnoDB Cluster, you're either mixing replication technologies or really with active sites, it's just not supported. Um, so again, DR failback, that's going to be a manual rebuild with InnoDB Cluster. But that's out of the box, and tungsten clustering, that's part of the product. And backup and recovery, both of them can use the tools that you're used to, MySQL dump, extra backup, or maybe snapshots. Whatever tool you want to use, they work with both products. Um, Scaling, tungsten clustering has primary and replicas. InnoDB cluster does have that as well, or you can have all active nodes. But when we talk about scaling, so we can distribute reads over our read replicas or our additional nodes in InnoDB cluster. Physically, we can deploy either product anywhere we want, whether it's on-prem, in the cloud. But with tungsten clustering, now we get the kind of hybrid cloud, multi-cloud, or multi-region deployments. InnoDB cluster, we're going to deploy in a single site only. Uh, Again, scalability, choose whatever size you want, just make sure it meets the minimal requirements, and that's fine for both products. Same with auto scale. There's nothing inherently baked into either product for auto scale, but you can manually scale your nodes how you're used to doing it, whether you have some process or manual steps. For cluster scaling, again, tungsten clustering is just ideal for SaaS apps, and it supports a pod architecture really well in automation. And InnoDB Cluster also really supports a pod architecture. And again, both of these products can be automated to deploy new pods. So at the geographic level, this is where the kind of the tungsten clustering product shines because it's built into the product. So you can have read replicas across availability zones, clouds, regions, whatever you want. You can have active geo clusters deployed worldwide with tungsten clustering, and active passive clusters, again, deployed at the geo scale with tungsten clustering. With InnoDB Cluster, this really isn't an option. The best really that you could do is mix replication technologies and deploy like an active passive cluster, but that's going to be pretty hard to manage when you start mixing two technologies. And if we look at active clusters, that's just not going to be supported with MySQL InnoDB Cluster. Interesting with performance. So because tungsten clustering has such a powerful MySQL proxy that's called the Tungsten Connector, um, there are features like load balancing and smart scale where you have automatic read-write splitting without changes to your applications, and then a bunch of load balancing algorithms within the connector. So with MySQL router, which you would use with InnoDB Cluster, it's a pretty basic proxy. It does port-based routing, and that's really it. It does handle failover, but your applications are going to get disconnected. Um, Up-to-date read replicas. So InnoDB Cluster has eventual synchronization, right? Using virtually synchronous replication. And tungsten clustering uses asynchronous replication. Asynchronous replication is going to be more robust in terms of performance, and it really doesn't add any penalty to your writes. The synchronous elements in InnoDB cluster can cause a performance hit when you're doing a lot of writes in your cluster. So transparency, how do the applications see the cluster? Tungsten clustering, no application changes at all. Your applications, as far as they're concerned, are talking to a regular MySQL database. InnoDB cluster does handle this well, except that there are certain SQL constructs that are not going to be supported. Version support. Tungsten Clustering supports native, enterprise, community, all versions of MySQL. With InnoDB Cluster, you're going to be using MySQL either 5.7, but most likely 5.8, as it really adds a lot of critical features and a lot of fixes. So it's limited support for your MySQL versions. You're going to be using MySQL version 8. Tungsten clustering is compatible with all database engines. InnoDB, MyISAM, whichever engine you'd like to use. Maybe you have some legacy databases or legacy tables that are using an engine and you really don't want to change it to InnoDB, you're fine with tungsten clustering. InnoDB Cluster supports InnoDB only. Uh, how about security? Well, both of these products really handle security kind of in the same way. You can use your favorite tools to encrypt your data at rest. In flight, there are methods for encrypting all the data in flight. And you can use this in, say, a HIPAA deployment or PCI or any sort of standard where encryption and privacy is required. Both of these products really do handle that without an issue. With deployment, both are easy to deploy. Well, with InnoDB Cluster, you're using MySQL shell. So that's the wrapper that makes it easy to deploy. Cluster management. So Tungsten Clustering has command line, InnoDB Cluster also, but Tungsten Clustering adds an intelligent web-based GUI. That's going to have monitoring. It's going to help you deploy, and you can really do all your management with the web-based GUI. InnoDB Cluster does not include a GUI, so you're going to be using command line. And alerts. So again, integration with notification systems, API, really both of these products handle it that way. Tungsten Clustering has a few more options for integration with notification systems. For instance, using standard Nagio scripts and Zabbix. And with the GUI Tungsten Dashboard, there are a whole bunch of options too for alerts and notifications. And again, patching DB, we want to be able to keep our application up and running, even though we need to patch our database or maybe the OS or maybe the actual machine itself. Again, both of these products support it, assistance with scripts, and you can do this with no downtime. What if we want to get our data out of our cluster and say into an analytics engine? Tungsten clustering supports this by using the Tungsten Replicator. Tungsten clustering can replicate out of the cluster and into a data lake or an analytics engine, no problem. The Tungsten Replicator also can do complex filtering and data transformation. So for instance, you'd want to get all your data out of MySQL, but you probably don't want stuff like blobs or other stuff that's not going to be useful in your analytics database. So Tungsten clustering using the Tungsten Replicator can filter out that stuff for you. And Tungsten Replicator, of course, is cluster aware, right? It's part of the Tungsten clustering package. So it's going to be aware of what's going on in the cluster and what node is primary and what nodes it can read from. With InnoDB Cluster, it's kind of limited. You can use native replication, maybe some third-party or DIY tools to try to replicate your data or export your data from the cluster to your analytics engine. You have sort of basic filters. It's not, you got to be careful when using this in multi-master. I mean, all your cluster nodes really need to have the same data when you have multiple primaries. So again, it's kind of, you can use MySQL native replication, and that's going to be async. The number of targets, though, is going to be limited to where you can replicate that to. How about support? So again, Tungsten clustering, part of the product includes support, 24/7 support, really with 100% customer satisfaction. We're actually quite proud of that. We respond extremely quickly for urgent calls. We average less than 3 minutes for urgent support requests. And everyone in our support team has at least 20 years experience, whether that's being a DBA, site reliability engineer, Linux admin, combination of all those. InnoDB Cluster can get kind of expensive. It could be 10K a year at a minimum, and that's when you're using a 5+ socket server. So it depends on the number of sockets in your server. Tungsten clustering support is really just based on number of nodes, and that's it. When you have enterprise support, the goal is 5-minute response time for InnoDB cluster. As far as support team experience, we don't know, right? But it would be logical that your first line support maybe doesn't have as much experience, and it has to be escalated to the next tier for anything involved. Version support. Tungsten clustering supports MySQL Community, Enterprise, MariaDB, Percona Server, and all versions. InnoDB Cluster, really version 8.0, right, for MySQL. Obviously, MariaDB, that's not going to be supported out of the box unless you go to MariaDB itself. But really, you'd want to use MySQL version 8.0. Okay, and where can we deploy this? Well, we can deploy either product on-prem, in the cloud, in a single site. But when we talk about multi-cloud or hybrid cloud, again, Tungsten clustering is fully supported because it's in the product of being able to deploy into multiple locations. With InnoDB Cluster, deploying into multiple locations or multiple clouds, that's going to be pretty complicated. It's basically a DIY deployment at that point. How mature is the product and complete? Again, Tungsten clustering, it includes everything you need for HADR and Geo-Scale. It comes with all components needed, manager, proxy, and replicator. And it's been in use processing billions of transactions for well over 12 years. InnoDB Cluster really just includes a very simple proxy, and there's really no multi-site deployment with InnoDB Cluster. It's fairly complete, but again, the proxy is simple, and it's coming from MySQL, we would expect that this would be tested, but it's not widely deployed as other technologies, right? It's fairly new. And when we look at total cost of ownership with Tungsten clustering, we don't care about instance size, number of sockets, or anything like that. And the pricing is non-linear. So if you're deploying 100 clusters, it's not 100 times more than one cluster, right? Again, it's a non-linear pricing. So adding additional clusters really doesn't make the price go up that much. Your 24/7 support is 100% included. And, we see companies deploying a large number of these clusters without a lot of DBAs. A small number of DBAs or maybe a single DBA can handle deployment of many clusters. InnoDB Cluster, it's either free with absolutely no support or expensive with support. So if you want 24/7 support, you can get it, but it's going to be a high price. But again, with automation and the proper tools, this could be managed with a small number of DBAs. So looking at use cases, when we talk about HA, again, both products handle this quite well. And that again goes to zero downtime maintenance and continuous operations. But when we talk about DR, there's really no offsite DR for MySQL InnoDB Cluster. And when we talk about active passive clusters, active clusters, or deploying clusters at the Geo-Scale, that's not supported with InnoDB Cluster. But with Tungsten clustering, this is all supported because it's all part of the base product. So I've spoken about Continuent solutions. Let's talk about our products just at a glance. We really have three main products: Tungsten Clustering, Replicator, and Dashboard. Tungsten Clustering, this is what we've talked about, right? Continuous MySQL operations, zero downtime maintenance. We deploy Geo-Scale. We deploy using multi-cloud or hybrid cloud technologies. We include an intelligent proxy that does automatic read-write splitting. And we support any version of MySQL. And again, that's MariaDB or Percona without any changes to your applications. So I've talked about our customer service and our support. Um, Again, we have a 1 hour SLA for urgent cases. Those cases we track very closely. We end up really less than 3 minutes for our initial response. So that's why our customers are able to measure their uptime really in years. And um, we all have experience with cloud technologies, Linux, systems administrations, and site reliability engineering. Uh, so, how does this translate into cost savings? Well, first of all, use whatever MySQL that you're used to using, right? If you want to use the free open source MySQL, that's fine. We fully support that. Um, you can choose which cloud environment you want to use um, because we run on any cloud environment. So if you get a deal with a particular cloud provider, feel free to use it. We run in any cloud provider. So that's one way as well that this optimizes your costs. And of course, downtime uh, can be looked at as a major expense. So we eliminate the risk for downtime and those costs, and that includes your maintenance operations. And DBAs can spend more time doing, what DBAs should be doing, improving the performance, rewriting queries, um, doing architecture, instead of, really menial activities like admin and recovery. So again, continuous MySQL operations. So we do HA. We've been doing this for 15 years, and our failover is immediate. So there's not an interruption to your business. And your MySQL recovery time now, if there is, any sort of catastrophic event, could be reduced to seconds, right? And our dashboard provides a graphical view and maintenance tool for all clusters, whether they're geo-distributed or not. And we'll look at that in a second too. With zero downtime MySQL, we can do site level and cross-site failover really quickly, right? This keeps your applications online and it keeps them from being disconnected as well. And that's because of the uh, Tungsten Connector. This is great also for upgrading hardware, software, doing any OS patches, again, without taking your applications offline. And we're fully MySQL compatible, well, because we're using real MySQL underneath. And it's really whatever MySQL flavor you would like to use. Of course, one of our big strengths is the Geo-Scale MySQL. We can load balance MySQL read operations across multiple replicas. We can use replicas locally. We can use replicas deployed on a global level so that applications can read from a local replica. Again, geo-distributed MySQL clusters bring your data closer to your application users for better performance and faster response times. And you can add MySQL clusters for scaling. You can add MySQL nodes too, as well, if you want to do scaling that way to add more replicas for better response times for your reads. Uh, because we are agnostic when it comes to cloud or whatever sort of hardware is underneath, you could deploy in the cloud, you can deploy in VMs, you can deploy on-prem. You can mix and match clusters as well. You can have a geo-deployed cluster with one site, say in Amazon, one site in Google Cloud, and another site on-prem. It really doesn't matter. But you can also fail over and fail back from these different private and public clouds or whatever platform you're using. Um, and obviously, if a node or a provider or any sort of regional failure happens, it's easy to fail over. to another site or another provider. Tungsten clustering includes an intelligent MySQL proxy that we call the Tungsten Connector. And it really has a lot of features, but the important feature that we want to point out, at least in this context, is that it's traffic routing. It will route to a local primary. So if we have multiple primaries deployed in different sites, it'll route to the local primary, and it can route read applications or read queries to local read replicas. And during any sort of failover event or switch event, applications are not disconnected. So your users still have a good experience even when a failover happens. And we can do kind of really cool replication with filtering, transforms in flight. Uh, if you want to use, say, replication to a non-MySQL target, we can do that. So you don't need ETL anymore. You can do real-time replication right into your analytics, and your analytics is up to date at all times. Um, and with the Tungsten Replicator, there's no charge for the amount of data or CPUs. It's just a pipeline. And we just replicate all the data from your cluster or your MySQL source to whatever target you choose. Again, this is a bolt-on application, so it's fully MySQL supported. We can use any sort of MySQL that you want, any flavor, no changes to your application. Just deploy and configure your MySQL cluster, and it's minutes. You use the same MySQL that you're familiar with. So whatever version that is that you want to use, that's what you can use. And there's no difference in your MySQL configuration. We do support SSL, which is extremely important. SSL for all in-flight traffic. So that could be your queries, replication traffic, or even the internal cluster communications, all SSL with encryption. And of course, native MySQL support. Another product too, we haven't really talked about it much, so I'll just go over it really quickly, is the Tungsten Replicator, right? And that allows us to replicate from MySQL to a bunch of targets, right? Again, we can actually replicate to Aurora or RDS, but more importantly, Redshift and analytic targets, right? Vertica, Hadoop, Kafka, there's a bunch, Cassandra, Elasticsearch, and this is really useful for multiple clusters. So for instance, if you have multiple MySQL clusters deployed and you need all the data and all these clusters to be merged into a single target, like say a Hadoop target or Vertica, the Tungsten Replicator can handle that for you. And it'll do all kinds of complex filtering. Typically when you're running analytics, you don't really need every single piece of data, right? Especially blob data. We can filter that out for you. So just the data that you need to get into your analytics gets replicated to your analytics. It's really flexible. There's a whole lot of filters that you can do and transformations of your data as well. And if you want to give it a shot, it's available actually as an AMI in the Amazon Marketplace. You could fire it up and it'll prompt you with the sources targets and it'll happily go along. So feel free to try it. Uh, One other target, just our product, just really quickly, uh, Tungsten Dashboard. This is our GUI management tool for tungsten clustering. So with this, you see your entire cluster. Even if it's geo deployed, you see all sites on a single page. You don't have to jump around between different sites. And you can do all your maintenance here. You can see our global transaction ID, the replication progress. You can switch. So switch a primary and a replica to promote a replica to primary. You can do failovers, and it also does monitoring as well. So this is a really powerful tool. And if you're using tungsten clustering, it'll manage all of your clusters again on one single pane. And the best thing is it's included with tungsten clustering. So you don't even have to pay extra for it. All the monitoring and everything is included. So if I can just talk about Continuent as a company real quickly. Again, we've been around for a while. It's been over 15 years already. And we only have experts here. Everyone is an expert on replication, databases, site reliability. Our support team, again, same sort of experience. Everyone on the support team has at least 20 years of database and high reliability experience. And that allows us to effectively respond to our customers' needs, questions, or even just to chat about architecture or technology. And of course, we're extremely proud that an urgent case we typically respond in less than 3 minutes. That is our average response time, less than 3 minutes. So that's another reason why our customers stick with us because they know when, if they have an issue or a question, even, they can get a hold of us. So here are some of our customers. And these customers have been with us for a long time, and it spans a lot of different industries: the medical industry, uh, finance, technology, telecommunications, and gaming, as well as some other industries. So we're pretty well represented in the enterprise space and software as a service space. And why do they choose Continuant, or why did they? Well, we've on all of our surveys, we have 100% customer satisfaction rate. And that is our goal. We're constantly thinking about our customers and we want that 100% customer satisfaction. And that's what we work for. Uh, Renewal rate, again, 97.5 and multi-year renewals. And of course, companies get bought out and they may have to adopt different technologies. They may even go off of MySQL. And so that would account for like the 2.5% that don't renew, but that's a pretty small percentage, and it's usually due to a buyout. Again, average response time less than 3 minutes for urgent case, and that helps fuel the 100% customer satisfaction rate. And our average customer has been with us for 7 years, so we do value a long-term partnership. That's another thing that we work for is that long-term partnership. We're not looking to, for a 6-month commitment and then say our goodbyes. And just some interesting facts. So we're the MySQL availability company established in 2004. And I've mentioned some of the industries that are represented with our software. Um, but a couple interesting things. In 2014, we were actually acquired by VMware, and we were going to build the database as a service for vCloud Air, which was VMware's cloud offering solution. Uh, Unfortunately, VMware, or maybe fortunately, but VMware abandoned their vCloud Air, and so with that, Continuent broke away and became independent again from VMware. So it was kind of interesting being selected to work with VMware. So that's a pretty big company, a pretty big player in the space, and we were quite glad to work with them. But now we're back on our own, and we decided to release some hardened security features in 2017, which is critical, especially in the cloud space. And in 2018, again, even more changes and more improvements to our multi-site clustering uh, offerings. And we saw our first 10-year anniversary this year. And now in the future, feature is cloud. So stay tuned for Tungsten Cloud. Anyway, thanks so much for listening. Again, my name is Matthew Lang, and there's my email address. Any questions or you just want to chat about tech or anything else, feel free to drop me a line. Would love to talk to you. Have a great rest of your day and make sure you see the rest of the High Noon series. Thank you.